how do we look at this? This length from here to here represents the entire length of the saxophone with all the keys closed, that we call a low B flat. All right, so from here to here, length of the saxophone, low B flat, all the keys closed. So the thing is about a saxophone is that it doesn't produce sound in whole wavelengths. It produces sound in half wavelengths. So let's redraw this so that it looks like this. All right, so this sound energy, it comes back, hits this point, reflects back, equal in magnitude, opposite in direction. Remember that? So we'll come back around this way. So this would be your low B flat. All right, so how do we learn from that? Well, what happens is when we play an overtone, we keep the same fingering. We keep using the same length of the saxophone, and this wave does something very interesting. So we can think about this as being one brick. One brick. So I'm just going to put a 1 right there. So if we keep this length exactly the same, when we play a low B flat and then overblow to middle B flat, this happens to the wave. And then it hits this point, it reflects back, equal in magnitude, opposite in direction. So now we got middle B flat, which is 2 bricks. So as you can see, a pattern is starting to emerge. This is middle F, this is 3 bricks. The saxophone only needs half a wavelength in order to produce a sound. Like I said, we produce notes in half wavelengths. Overblowing a low B flat gives you this middle F. So there is a mathematical formula that allows us to be able to calculate what all of these notes are, and you're already loosely familiar with it. This is the first 4 notes of the Overtones series on the saxophone. So we got B flat, low B flat, middle F, high B flat, and you get this number here, which is the frequency, and you get it by continuously adding 104 to the frequency, right? So when you do that, you can come up with a simple mathematical way of writing this, and you are already familiar with it. This is called sure you've heard about this before because you've already been doing it. I'm going to assume that you've already been practicing your overtones off a low B flat, but now let's write out the mathematical formula that describes what I just wrote out before in kind of longhand. So we can simplify that by writing this: 1 plus 1/2 plus 1/3 plus 1/4 ... etc. So this whole thing, this is the harmonic series. This is what you add to your fundamental or your low B flat in order to get the overtones that you do. So let's do that. So hopefully I got enough room here. If you have low B flat, which is 104, this number 1, this represents your starting point. So we want to add this thing in parentheses to this number. So we add 1, which is 104. Then we get 208. So 208 plus half of 208 is 104. 312 plus 1/3 of 312 is 104. So you just keep adding 104 to the whole thing, which is what I wrote up the first time. But now we understand what this harmonic series is. Now this is very specific to a saxophone. Like you try and do this on clarinet and you're going to get all the wrong notes. And technically speaking, when you do this to a saxophone on notes other than B flat, low B flat, then you're going to wind up getting wrong notes anyway. But this is the way this is written out. And I'll go into more detail about why you wind up getting wrong notes when you're not playing a low B flat later. But look at how beautifully simplistic this thing is. So a lot of people, they'll put this in their magazine or their saxophone book because other people have done it, but they don't really understand how it works, which is why it's so confusing. But for us, that's all you're doing. So if you're doing this on your own, make sure that you don't think about adding, because this is what I was doing before. So you don't make this mistake. I'll do it wrong on purpose, right? So you have 104. Okay, half of 104. That's 52. Oops. No. Doesn't work like that. You have to add this. We good? We good.